Hey guys, this is another video. It deals with stoichiometry. Okay, stoichiometry is the way that we convert from grams of a given substance to grams of a whole completely different substance, which we call the wanted. Okay. Now, in the past, when we used a mole map, we stayed with one substance the whole time, went from grams to moles to liters, grams to moles to representative particles, mole to liters, liters to moles, etc. But we never changed the substance's formula. In this case, we are going to be changing the substance's formula. Okay, so that's one important thing to note. Okay, now how do we do this? There's a few steps that are involved to create the formula in order to cancel out all the units to get the correct answer, okay, or to get the grams of wanted. So what you have to do is first, you're going to have to take the grams of given and convert it to moles of given. And you're going to do that by using the molar mass of the given. Then step two, using the mole ratio found from the balanced equation, convert from mole given to mole wanted. And step three, convert from mole wanted to grams wanted by again using the molar mass. Okay? Okay, so here's a little conversion. So if your substance is in any other unit besides grams, convert it to grams. But if it's in grams, you're good. So you start from grams and you convert from grams of a substance to mole of a substance. And that's going to be in mole of the given. Then you want to convert from mole of given to mole of wanted using the mole ratio. Then you go from mole wanted to mass wanted using the molar mass. Okay, so this conversion factor here and this conversion factor here can be directly found right from the mole map that we use. Okay, so let's take a look at a real problem here dealing with automobile airbags. Okay, sodium azide is used in automobile airbags. Sodium azide, which is NaN3, decomposes to form sodium metal and nitrogen gas. Okay, nitrogen gas is the gas that is used to fill the airbag in the car in the event there's an accident. If 40.7 grams of nitrogen is needed to properly inflate an airbag, how many grams of NaN3 are needed for the reaction? Okay, so here we have our given, which is 40.7 grams of N2. And our wanted is question mark, how many grams of NaN3? Okay, so the first step to obtain the information to canceling out the units to get the number of grams of wanted is getting the information from the problem. So we're going to go through a few ways to extract this information to come up with the correct conversion factors. Okay, so if there is no equation furnished, then you're going to have to begin by writing the skeleton equation if it's not given already. Okay, so in this case, it's a decomposition reaction where sodium azide breaks down to form sodium metal plus nitrogen gas. And remember, nitrogen is diatomic, so there's a 2 after it. After this, you must balance the equation. Okay, you can see there's 6 nitrogen atoms on the right, 6 nitrogen atoms on the left, 2 sodium atoms on the left, 2 sodium atoms on the right. Okay, step number 3 is to find the mole ratio. Okay, now you can find from the problem, determine which is your given and which is your wanted. So we already know that your 40.7 grams of nitrogen are your given. Okay, and NaN3 is your wanted. Okay, so that's that. So we can actually label this right here, our W. It's very important. All right, and this is our given. All right, now from the balanced equation, you can find your B and your A. Now your B is the coefficient to your wanted, which is the number 2. And your A is the coefficient to your given, which is 3. So then we can fill out these spaces right here. Okay, so your N2 is your given, your 3 is your A, your NaN3 is your W, and your B is 2. Remember, 2 goes in front of the NaN3, and the 3 goes in front of the N2. Okay, now we want to plug this information, which we just got from the balanced equation, into the mole ratio formula. So the B mole W over A mole G. So we take all this information, so we put the 2 here, and the NaN3 here, the 3 here for the A, and the N2 there for the G. Okay, so it equals 2 mole NaN3 over 3 mole N2. Now we want to also find the molar masses of the given and wanted. So we know N2 is our given, and NaN3 is our wanted. So we use the periodic table, refer to the atomic masses. Okay, there's 2 nitrogens, so each one is 14. So that'd be 28 grams. And Na is 23. Nitrogen's 14, there's 3 of them. So you add them all up and you get 65.0 grams of NaN3. Remember, round to 1 decimal place. So now we can start the equation, okay? So now the roadmap is to convert from 40.7 grams of N2 to mole N2 to mole NaN3 to grams NaN3. Okay, so this is our roadmap, and we're going to start setting up our data. So begin with information, given information. You must convert into grams if not already done so, remember. But in this case, this is already in grams. So here again, we're going to use these 3 conversion factors to get the answer. Okay, so we're going to multiply our mass in grams by the molar mass, which can be found on the mole map. Okay, so we have 40.7 grams of N2 times 1 mole N2 over 28.0 grams of N2. Now the N2s will cancel out. Now we're going to take our mole ratio, plug it into the next section, and the grams of N2 are going to cancel out. Okay, then once you put your mole ratio conversion factor right here, okay, we're going to see that the mole N2 and the mole N2 will cancel out. Now we're left with mole NaN3, and that's what we're looking for, but we're looking for grams. So we have to multiply it again by another conversion factor, the third one, which is going to be the molar mass of NaN3. Okay, so we put our molar mass right here, and then the mole NaN3 and the mole NaN3 will cancel here. And we're going to do the math. We're going to multiply everything in the numerator and divide it by everything in the denominator. Okay, and you should get 62.9 grams NaN3. Okay, this is the last unit left over. This is what we're looking for. This is our answer. All right. Now let's look at another practice example. Same thing. Okay, we're not going to be adding so many steps in this time. I just went over that really detailed, took a long time to do it, but let's look at another one so you can practice. Okay, so we have tin 2 fluoride, which is SnF2, is used in some toothpastes. It is made along with hydrogen gas by the reaction of tin with hydrogen fluoride. Okay, so the question is, how many grams of SnF2 are produced from the reaction of 30 grams hydrogen fluoride with tin? Okay, so now SnF2 is our wanted, and our 30 grams of HF is our given. So we're going from grams of HF to grams SnF2. Okay, first thing we want to do is determine our balanced equation. Oops. All right. Which is Sn plus HF yields SnF2 plus H2. Okay, got all that information from this equation here. All right. So tin plus hydrogen fluoride yields tin 2 fluoride plus hydrogen gas. Now, how do we calculate that? We start out with our given, which is 30.00 grams of HF. We want to go from grams HF to moles HF. So we used a molar mass formula, 1 mole over 20 grams of HF. Once we have that, we would then want to multiply it by the mole ratio, which is the BMW AMG. So that is 1 mole SNF2 over 2 mole HF. Okay. Then we want to go from mole SNF2, because these two will cancel out, to grams SNF2. So we have to multiply it by the molar mass. Okay. So here's the molar mass. And now mole SNF2 and mole SNF2 will cancel out. Then you multiply everything in the numerator by everything in the denominator, and you get 117.8 grams of SNF2. All right, guys. So that's basically it. This here, you can see your mole ratio. Your B is 1. Your wanted is SNF2, and that's what we solve for essentially. Your A is 2, and that's from the balanced equation. And then your G is HF, which is your given. Okay, and that's what we went from. That's what we started with. So we went from one substance to another substance. This is the mole ratio. It's very important. That's what stoichiometry is. Okay? All right, guys. That's it for now.